morning. Good morning, Australia. Good afternoon, California. And good evening, Washington, New York, and the East Coast. It's indeed a great personal honor and pleasure to bring to this conference Veena Sahajwalla. Veena Sahajwalla is a world-known individual in her area of recycling. Veena is a fellow IITian. She graduated from IIT Kanpur and then received a master's from University of British Columbia in Vancouver, and then came to the US and got a PhD from University of Michigan. Veena is an internationally recognized materials scientist, engineer, and inventor, revolutionizing the recycling science. She is renowned for pioneering the high temperature transformation of waste in the production of a new generation of green materials. In 2018, Veena launched the world's first e-waste microfactory, and in 2019, she launched her plastics microfactory, a recycling technology breakthrough. She's producing a new generation of green materials and products made entirely or primarily from waste. Veena also heads the ARC Industrial Transformation Research Hub for Green Manufacturing, a leading national research center that works in collaboration with industry. In 2019, she was appointed the inaugural director of the Circular Economy Innovation Network by the NSW government through its Office of Chief Scientist. She's known broadly as the inventor of green steel. So ladies and gentlemen, here is the green steel lady, Veena Sahajwalla. Veena?
Thank you. Thanks very much, Ron. And thank you for that kind introduction, and appreciate the opportunity to be here and share with you, our journey here in Australia on green steel, and the fact that we live in this beautiful part of the world in Sydney, Australia. It's actually been quite a journey where we get to not only do all the cool engineering and inventions, but we also get to work with people who are so passionate about the environment, about sustainability. So a lot of the work that we've been doing here, I have to acknowledge and credit the government here in Australia, and also, of course, a lot of our industry partners, without whose support, really, none of these inventions would have come to life. As we know very well, the journey of an inventor is very much about, first and foremost, when you develop your ideas, the next big challenge always is about how do you actually get it out into the real world. So for me, the ability to actually take green steel, and I'll talk to you about a little bit more about some of our other discoveries along the way, has been very much in partnership with industries right here in Australia. So steel making industries like Molycop, property companies like Mirvac, e-waste recyclers, global partners like Tezam. And the work, of course, has led to our ability to indeed show to the world that innovation is actually, in the world of recycling, is more than just thinking about recycling. It's actually very much thinking about how we make these materials useful so that they can have multiple lives. So we can imagine that your materials that come out of electronics and plastics and glass and steel, all of these different types of materials, if you can recycle and reform them many, many times over, then of course you are in that really fantastic position where you can actually bring your materials to life in many different applications. So as technologies evolve and grow, and the classic case, of course, is with our electronics, as these products are always going to change and develop and grow, how do we make sure that our ability to harness materials and resources that are so critical in this whole digital infrastructure that is indeed an important part of the future where we're headed, gives us the opportunity to harness materials, whether they are metals, plastics, glass. The ability to actually do that has been fantastic for us, in that we can indeed showcase that it is absolutely possible to actually create these fabulous materials. So if I can actually give you that bigger picture overview, the journey started, of course, as Ron, you pointed out earlier, around green steel, and a whole range of inventions that have then emerged out of that have led to the development of our microfactories. And indeed, our microfactories are really all about creating materials, as I said earlier, about circularity, which is bringing these materials back to life over and over again, not just seeing them as recycled materials, but rather seeing them as reformed materials. And why do I like to think of them as reformed is because we're reforming, whether it's about the structure, the chemistry, their properties, all of these abilities that we have at the tip of our fingers comes down very much to our ability to do science, engineering, and technology. So part of our work here is to think about, yes, it's about the transformation of our materials, but it's transformation so that we can indeed look at how we might be able to create value. And of course, when we talk about value, it's important that when we look at our materials, we put value in a whole different context. What are we putting value to? Are we putting value purely on the underpinning economics? So is it just about the economic bottom line, or is it more than that? And clearly, as we would all agree, as we've learned through 2020, that we have to be able to understand value in a broader context. So it's broader context because it's got to demonstrate value to our people, to our planet, our society, our environment. And so you look at examples like that of a simple tire. Waste tires, we know globally, are a massive challenge. Do we just see this as something that's to be left alone, out of sight, out of mind, or do we actually harness the potential in these waste tires? And this is exactly where, of course, the ability to think beyond traditional recycling. And what I mean by that is beyond just the conversion of, like for like. So you don't just think about converting tires into tires or indeed plastics into plastics, but rather imagine what we could do if we could indeed harness these materials in so many different ways. So when you think about a simple product that we use in our lives, a car, imagine that, of course, the steel is being recycled. We all understand that that's happening for a long, long time, but the non-metallics in there, imagine if we could indeed recycle all of those, our tires, our glass, our plastics. At the moment, of course, there are so many different types of plastics and materials that are used in a car that it is next to impossible to separate all of these materials out. So it's a complex mixture of different types of plastics and glass and so on. So how do you actually think about recycling? And the way we think about it is not just conversion of like to like, that is conversion of plastic back into plastic, but rather putting a lot of these materials into the making of steel. And why are we so focused on making of metals is because of the simple fact that our ability to actually utilize waste tires, and I'll come to in just a moment as to what we're doing specifically in steelmaking, and using these waste tires in the process of steelmaking not only allows us to harness traditional elements like carbon, which we rely on typically from coal and coke, but rather we can now harness carbon from tires and plastics and use that for these types of reactions in manufacturing processes. And so, for example, in this case, if we can utilize waste tires, we can reduce our dependency on coal and coke. So you can imagine that we can absolutely reduce our carbon footprint. That's a one big feature, of course, of why you would take these types of materials. Why would a steelmaker find this of value to their business would be because of the fact that it actually not only allows them to reduce their carbon footprint, but it actually allows a steelmaker to utilize waste. But the other important icing on the cake in this particular case is that the fact that we can actually rely on the all-important element hydrogen that is also present in tires. So the fact that we can utilize hydrogen effectively now allows us to utilize all of these key elements, both carbon and hydrogen, in the process of making steel. And we deliver hydrogen in a really innovative manner in these types of manufacturing technologies. So we are creating hydrogen in situ, we are utilizing hydrogen in situ, that, as you can appreciate, reduces carbon dependency and therefore reduces our carbon footprint. But the important video that you're seeing in the middle of the screen there is actually demonstrating the kinds of micro level reactions that are taking place inside an EAF steelmaking furnace. That actually shows that the hydrogen molecules that we do generate out of tires is actually extremely efficient. So this is a whole new way of thinking about harnessing hydrogen for metals production. And that opens up a new realm of possibilities, looking at how we can then go back and harness these types of elements right down at the elemental level, allows you to suddenly create innovative pathways to not only reform tires, but also then look at all the other important elements that are present right across the entire ecosystem. And that's really where, of course, the whole sort of thinking about circularity of materials comes in. And when I talk about circularity of materials, what I'm really trying to show here is that regardless of whether you work in industry or whether you're as a small business or a community member or someone just at home looking at, you know, what's going to happen to all these different kinds of materials, whether it's about your electronic devices or, you know, food packaging, all of these different types of materials have inherently got a lot of energy and materials that are embedded in there. So imagine your snack packets, for instance, they've been lined with aluminum. These types of materials, of course, at the moment will typically end up in landfill. But imagine if you could take your food packaging and harness a lot of the metallized packaging for the aluminum content, for instance. Imagine if you could take your electronics and harness those. And imagine if you could actually do that in a way that you can indeed set up production facilities. So if I'm a manufacturer and I'm looking as an SME, a small to medium enterprise, looking at the possibility of actually doing this productively in a decentralized manner. So I don't need to set up mega factories, but if I could actually do that on a small enough scale, create highly valuable materials, I've actually not only addressed the issue of local waste resources, but actually minimized the transportation of waste over long distances, created, importantly, local jobs in my local community and local towns. All of this means that as producers, as designers, as manufacturers, we actually can have a big role to play and participate in the whole circular economy that the world, of course, is looking to developing. So circular economy very much is a role of what inventors actually can play a part by understanding where the needs are, where the demand is. And ultimately, of course, it all comes down to market and the market pull. So you can imagine as an end user, if you're in a sector, for example, in the construction sector, if you're looking at accessing and procuring materials for the built environment, how do you actually make those choices? And it's so important then that we all in our jobs, in our everyday lives, can make those important choices that allow us to make decisions where we might choose more sustainable products. And that's an important call that we can make. How do we choose to spend our money? And that then means circular economy solutions and the circular materials that we're talking about here can actually see that whole sort of market demand growing. So this is where, of course, we can play a part. And this is exactly the kind of work we're doing right here in Australia. So you can again appreciate that it's not just about tires, but electronics, as I was telling you earlier. E-waste is an interesting, I guess, minefield, if you can call it that, that, we love our electronic devices. It's an important part of our lives. But what do you do when products become obsolete and you're moving into the next model or the next product? There's a lot of materials like our metals and of course plastics and glass that are embedded in our electronic devices. So how do you actually harness those? How do you do it in a way that you can decentralize and have these micro facilities distributed across the world? This is where, of course, the invention and the technology of microfactories that we've been developing comes in, where you can look at actually positioning these microfactories in different parts of the world, whether you're in an urban center or a remote or regional community. For us, that's an important question in Australia. Massive land mass, of course, and so many regions that are far away from urban population centers. So this is where, of course, microfactories become important because you can actually work with small volumes. And once again here, what this video is trying to show you is how we can take, for example, our circuit boards, which you see on the left-hand side of the screen, and create these copper-based alloys. And what you're seeing in the middle of the screen is how our micro-recycling science actually has given us the ability and that capacity to actually generate these important metal alloys. We can customize these metal alloys. We can produce a whole range of different types of materials, of course, that are fit for purpose. So when we talk about microfactories, we talk about micro recycling. It's a very different kind of business model. It allows us to move away from the traditional way of thinking about large economies of scale. It allows us to start to think about economies of purpose. So that whole mindset shift is absolutely important. We need to start to think about, when we are talking about economies of purpose, the purpose there is to create highly valuable niche materials that are fit for purpose for different types of applications. So, if you're looking at, for example, the next generation of energy storage devices, where are those materials going to come from? And so, imagine if you had to harness rare earths. And are you going to always rely on mining operations? Or are you going to look towards existing obsolete electronic devices that might be present in landfill, and you could well harness those? So that's exactly what we're doing. We're actually harnessing rare earths out of our electronic waste so that we can bring them back to life again and again. And indeed, when you look at waste batteries, an example, of course, just a simple item in our everyday lives, whether they are the tiny disposable batteries or indeed lithium-ion batteries, the important question is, we need important elements, whether they are elements like cobalt or indeed nickel, manganese, zinc, and so on. What we have shown here at UNSW in Sydney is that we can indeed produce a lot of these materials, and we can produce them in the right form and the right chemistry, and that then allows us to put them into different types of applications. So that's really the importance of the learning from out of this is it's more than just doing recycling. It's actually harnessing and producing these green materials that are fit for purpose. So regardless of what your devices might look like, so when you're talking about energy storage devices, whether they are going into solar batteries or whether they're going into your everyday items, disposable batteries, if you can indeed see them as renewable materials that can be reformed over and over again, then it creates a whole new range of opportunities for your local communities, small businesses, and be very much part of that supply chain globally. And indeed, this is where microfactories in Australia are proving that we can set up to the right scale. So if you want to set up larger scales, you can have microfactories that have got multiple modules, and you can have that multiplier effect to grow the business as you need to. Or if indeed at the other extreme, you're in a small town, and you want to be able to set up a microfactory that is fit for your purpose, which is of the right scale, you can still do that. You are actually never compromising on the quality of the material that you're making. So that's the important message here again, that it's about creating the right quality. Sometimes people tend to think that if just because I'm recycling or I'm producing materials from recycled content, that it must be downgrading and downcycling the materials. But indeed, that's not what we are advocating. We're talking about our capacity to produce these materials of the right quality and indeed producing them as green materials that are fit for purpose. So the goal is to keep our materials in our economy. Part of that whole circularity of materials is to have technologies that enable us to achieve those outcomes, regardless of what the product evolves and grows to become. And so our smart microfactories at UNSW, and we do operate these at our university as a demonstration facility as well right here in Sydney. So this is what Smart Center does. We're not only looking at the fundamentals of recycling and materials and that material transformation, but what we are also doing is developing these new technologies that can then be translated across into various applications. So this is about ultimately producing technologies, materials that are sustainable. But the important question is, how do you then translate and take a solution from the labs into demonstration units, and then from demonstration into commercial units? And this is where, of course, partnerships across the board are important. Our technologies of green steel, for example, have also been taken out commercially to different parts of the world, including, of course, in Australia. So this is really where you can see the entire system, and how it works is where we laterally integrate different types of people in the supply chain. So you might be somebody who's got waste electronics or tires, but you might then connect with end users who might sit completely outside your space. So what we have shown is that what you're creating in a business model sense is a lateral integration. The lateral integration shows that that partnership and collaboration could well be that I might be able to produce metal alloys from my waste packaging, but that high quality aluminium that I'm producing, that could then be fit for purpose in a completely different industry. I might then be able to take my plastics coming out from my electronic sources and create plastic filaments that are fit for 3D printing. And so the list goes on and on. We are showing that all materials coming out of our end-of-life products can actually be harnessed. And the ability to actually laterally integrate that across various technospheres is important. So it doesn't matter what business space you work in, you have to be able to look beyond your traditional boundaries and look at opportunities. So whether it's our built environment where we utilize waste glass and waste textiles, and I'll show you a couple of those examples, or indeed whether it is our metal producers or electronic device producers, we can actually take this whole notion of what we mean by micro-recycling, selectively synthesize the right material, fit for purpose, put it right back into manufacturing. So that's really where the fourth R comes in, our ability to go beyond the 3 R's of reduce, reuse, recycle, and take it into that whole new value equation, the conversation of waste to value, where our materials are transformed into new applications, is where the fourth R of reform comes in. And that's absolutely critical, because our products, we know, are really complicated. So we cannot imagine traditional recycling technologies being able to solve this whole complex challenge ahead of us. And this is why, of course, our reform technologies are important. But how do you actually go about taking materials through that journey when you might start with something that's a complex feedstock, like we've talked about our batteries and e-waste, and even different types of plastics coming from our cars, for instance? How do you actually then take it through that journey where you've got commercially viable and operationally and technologically viable solution? So the fundamentals that we develop, then run those through our microfactories at UNSW, that then allows us to develop these types of solutions in partnership with businesses, which is why, of course, the pilot trials are so important. And regardless of whether it's a small business or a large corporate, those fundamental principles are important, that partnership and the collaboration journey allows us to accelerate and take these kinds of ideas and make them mainstream. And that's exactly what we've been doing with a whole range of different types of materials, from our tires that I talked about to electronics. And indeed, the whole vision of the Smart Center is very much about, one, is to be able to create these highly valuable materials. But the second important impact on our societies and impact on commerce is that we can create and encourage and support local economies to grow. And of course, the most important thing right now, front and center of minds as we are looking at the impact of COVID globally, is to be able to ask the question, what is that economic recovery going to look like? You know, whether you're in the States or in Australia or in India, doesn't matter what part of the world you are in. One thing we all have in common right now is that we all have got end of life waste materials, you know, whether they're coming from our hospitals or indeed a whole range of other areas. And on the other hand, the all important question, how are we going to create jobs, new jobs, and really push forward economic recovery? This is where, of course, we can start to imagine these new supply chains of new materials, delivering products that are fit for purpose for our economy. And so we're never going to stop using electronic devices. We're never going to stop using materials and products that go into our everyday lives, our cars, our electronic and communication devices. So why not imagine a future where you know, a material that comes out of waste can be reformed, and we've unlocked the value that's there in those waste resources, and we can actually show to the world that it is absolutely possible to create safe transformation of waste into sustainable materials. So that's really what microfactories are all about, is demonstrating these types of technologies. And we are indeed putting these kinds of microfactories in regional towns. We're about to unveil our next big microfactory in a small regional town, not too far from Sydney, in a town called Cootamundra. And I think, to me, it just goes to show that the passion and basically the desire and the motivation amongst businesses to make a difference, to create impact and to create jobs is so high. We are absolutely honored and humbled and privileged to work in Australia, where we've got the opportunity to work with businesses who see this as a real tangible solution for local economies. And of course, for us, we would love to be able to imagine that this then has such a massive impact on the world potentially, and that opportunity is there. So imagine, of course, capitalism where we are underpinning values that, of course, are both about caring for our planet and caring for our people. And this is important. But how do you make it happen? So these kinds of microfactories that started its life at UNSW, what you're looking at here is one of our microfactories at UNSW, our e-waste microfactory. We've got, of course, a whole range of materials. It's a journey that, of course, in a way for us also has demonstrated that it works, but we clearly have a long way to go as a global community. Take, for example, our e-waste. You know, it is one of those big challenges that we know very well, that people might look upon e-waste as this complex mixture of both metals and plastics. Can we actually harness not only the metals, but can we also harness our plastics? And this is an example of what we have harnessed them into. You can see waste hardware parts coming out of printers on the left-hand side, plastic filaments in the middle, and us doing 3D printing on the right-hand side. And yes, we absolutely can show that the economics works, plastic filaments, which then can be used for 3D printing. So that entire microfactory can actually be self-contained, starting from waste and creating highly engineered and manufactured products for our economy. We can then start to ask another important question that is, of course, near and dear to everyone's hearts, and we're all aware of it, is the all-important question, what do we do with our waste textiles? Again, a global challenge. We know globally lots and lots of waste textiles that will end up in landfill or get incinerated. Same problem right here in Australia. So we're working towards utilization of these types of materials in a completely unique way, where we are combining waste textiles with waste glass. So you can see an example of a product here, a glass panel example that we've created by combining textiles and glass and other materials that allows us to create these really hard green ceramics. And we can put these green ceramics, as we have done in partnership with a property company here in Sydney called Mirvac. We've then put those into various applications, whether it's furniture or inside various fixtures. And they're about to unveil the next project coming up in the new year that we have just delivered on, that allows us to show that these hard green ceramics can indeed have fantastic properties that are fit for purpose, engineered to deliver the right strength and of course the right properties mechanically, as well as of course in its ability to withstand the day-to-day requirements of such applications. So the important point in these microfactories are that they're fit for purpose. They are indeed ready so that they can be globally deployed, and they take us away from this traditional thinking around the current system of linear economy. That's what we're used to thinking about, using our products and disposal into landfills, and taking us into a far more circular economy around our materials coming back to life over and over again through different forms, whether they are through reform, recovery, recycling, and remanufacturing. So finally, just would love to leave you with a few thoughts here, how the journey that we have started here in Australia around creating these microfactory solutions will allow us to ultimately play a small part in delivering these types of decentralized solutions that deliver, of course, both jobs and economic benefits. So that whole new way of thinking about capitalism that can use sentiments both from our hearts as well as from our heads, bringing those two together allows us to deliver a better outcome for our people and for our planet. Thank you very much. Thanks for having me, Ron.
Great, great. Thank you, Veena. Very, very, very excellent presentation, I would say. And I have tons of questions that people have sent us. And so I'm going to just out of those ask maybe 3 questions.
Sure.
And first is that quite a few questions on your work and its relationship with the UN SDGs, the sustainability goals that the United Nations has set. Yeah. How involved have you been with the UN on these SDGs?
Yeah, so very good question, Ron. And of course, I can point to, for example, SDG 12, responsible consumption and production. And if you think about fundamentally, how when we talk about responsibility, it has to be around both consumption as well as production. And so from our point of view, right here in Australia, we've got, these types of circular economy initiatives that governments have been supporting. So in my role in leading up the innovation networks is to be able to showcase that technology doesn't just sit in the hands of businesses. Technology and the implementation of these ideas has to be such that it's accessible. So local governments, local councils excited about some of this work means that they can actually start to deploy these products. So we've got a local council, for example, in Sydney, that recently launched these products in its community center. So when we think about SDGs, it means that ultimately the utilization, so that's the consumption part of it, you make that decision to consume products that indeed have been made out of recycled content. And this is where the connectivity of technology to people and utilization at the grassroots level is so important.
Great, great. Thank you. Thank you. Second question is very close to you and majority of the audience. Mm-hmm. That's about IITs.
Yes.
How can IITs help you with this recycling effort? Right. And what can you do to reach out to them, to engage them in a more active manner?
Right. Thank you for that question, Ron, because I've got to say, I mean, I was born in Mumbai and and of course, you know, I mean, a lot of those fundamental core values of, you know, what I'm talking about here in terms of recycling, it's not new. Fundamentally, it sits quite nicely with a lot of people in India. And I know growing up, as I'm sure we all did, you know, where your family values were very much about respecting your materials and the clothes that you wore, and you did your hand-me-downs and gave it to your younger sibling. I had my younger siblings, you know, boy, my brother, I'm sure he didn't quite like to wear my dresses, but, you know, I tried. The point I'm making here is that it is very much about ultimately, you know, when we think about how education has evolved from an engineering context, we've very much become holistic in the way engineering and science and technology and all of these disciplines actually are not just about focusing on the teaching of the technical attributes, but rather the more holistic way of thinking about what does it mean from a social and an economic point of view. And a lot of students who've approached us from IITs, who've come to us to spend a bit of time with us doing their internships and doing their masters and PhD. And we would love to, of course, have the best and the brightest. And a lot of people who come from India love doing this kind of work where they can see the impact of their work on society. So I think where that education has grown in its thinking over time has been to start to imagine what you study, how it then has an impact. So absolutely, the way I would love to connect with IITs, we've got programs, Australia-India collaboration at the moment that has been started this year around reduction of waste plastics. I would love to imagine that we've got a lot of students from IIT who would, you know, who would love to participate in collaborative programs like that. Happy to connect with those programs of Australia-India collaboration waste, you know, plastics reduction. So I think to me, that's an important feature is participation in these types of programs, understanding in a global context, how your education can really have such a massive impact on the planet can be quite exciting and very motivating for young people.
Thank you, Veena. Thank you, Veena. Let me take now about a minute to close this out. First of all, you're speaking on a Sunday.
Yes.
Okay, and it's Saturday here. And so we appreciate, you know, all the effort over the last couple of months I've been dealing with you for you to adjust your time and availability for us, which is amazing. And that's a spirit that IITians have all across the world. Now, your topic, your discussion has been very appropriate for our conference. And I'd like to end it with 3 words, or 2 words really: reimagining future. You mentioned that in your discussion, reimagining future. And that's what this conference is about. Future is now. So Veena Sahajwala, Pan IIT, salutes you, thanks you, and take care. Thank you.
Thank you. Thank you so much for having me. Thank you. Appreciate it. It's an honor. Thank you, Ron.
Thank you,
Veena.